Okay, now what we want to do is we want to start figuring out if a table is linear or nonlinear, and we can do that by trying to figure out what the slope is. But this is kind of an archaic way, but if I were to go through and pick this as a point and this is a point and then calculate the rate of change, and then I'd have to do this one and this one. Remember, a point is two values, not just one value. So it would be this one and this one, figure out what the rate of change is there, what the rate of change is between these two, what the rate of changes are between those two. Once I figure all that, if they're all the same, it's linear. That's a kind of a difficult way to do it. So if I were ever asking you to do something like that, instead, what I would actually prefer that you do when you're doing something like this is graph those points. And so I have 1 in -4. I have 2 and -2. I have 3 and 0. I have 4 and 2. I have 5 and 4. So I can go figure out all those things and figure out all those, but I could also just draw it and see if it's a line. Remember that a straight line has to be straight. It cannot have any turns in it. It cannot be a V. It cannot be anything like that. So in this case, I would do that. Now, if we wanted to figure out what the slope was, just pick 2 points. It doesn't matter which 2 points. So let's say, okay, I'm going to pick, instead of picking two next to each other, and I'm going to pick one with a 0 in it because it's easier. Well, let's say I pick these two. So this will be 0.2 and this will be 0.1. And it doesn't matter which points I pick. I've already shown that it's a straight line, but you'll see that it also calculates out. Whoops. And so what I have here is I want to look at the y values. It's not a good way to scratch them out when I have an opportunity to erase it. So it'd be 4 minus 0 because we have the y values. Here's my y2 and my y1. And over here is my x2 and my x1. So that's 4 over 2, which of course is 2. So that would be my slope, okay? And that's what we're looking at, or my rate of change, which means the same thing. Okay, so moving on to the next one. So this is the one that I do want you to see. So they do the same kind of thing on this, where they have you check to see which ones I believe are lines, which tables represent a linear function. Notice we'd have to do 100 calculations. That's exaggeration. But we'd have to do at least 1, 2, 3 on that one. 1, 2, 3, 4. 1, 2, 3 on that one. 1, 2, 3, 4. So we'd have to do 6, 8, 14 different calculations to figure it out. Okay. Not very efficient. Easier to just graph these things and see what happens. And of course, you can graph these on Desmos and check them out and see which ones are lines and which ones are not lines. So, and so we can do that on Desmos by just plugging in values. What's nice about Desmos is you can plug things in really nice. Make sure you log in. It's a good idea to always log in so that you can save things. It just allows you to do that. Go over to your graphing calculator and you will notice over here, let's just do this one because well, actually, let's do the fractions one because we're going to figure out the slope on this one anyway. So -1/2 and 7. So notice here with this little plus sign, we can create a table and we can have -1 divided by 2. There's -1/2 and 7. And we're going to plug in the values just to see what happens here. 1/4 and 9. So we have 1 over 4 and 9. And then we have, or 1 divided by 4. Remember that slash means divided by 3/8 and 11. So 3 divided by 8 and 11. And this just makes it so much easier. Everybody should learn this because it will make your life a lot easier, especially on a test. 1 and 13. And notice in this case that we have all those values. Those should be plotted. So -1/2 and 7. So notice I can't see them. So because I can't see them, oops, I don't want to zoom in. I don't want to zoom out. So there they are. Okay, notice, whoops, if you look at them, not a straight line. Okay, just by looking at them, you can tell it's not a straight line, so therefore that wouldn't work. You can go in and you can plug in the other values and kind of figure it out from there. I just want to show you how to do one of the calculations here. So we're going to look at negative 1/2 and 7 and 1/4 and 9. And we're going to do that calculation just so that you can see how to do it with fractions. So we want to figure out what that is. So of course, this is 0.2, at least what we're going to make it. This is 0.1, that's the one we're going to make it. So then we have, this is 1 and 13, and then we have 9 minus 7 divided by 1/4 minus a negative 1/2. Okay, that's supposed to be a negative there. So we really have 9 minus 7 over 1/4 plus 1/2. 9 minus 7, of course, is 2. We need to get a common denominator, so that becomes 2 over 4 because we figure out the common denominator between 2 and 4, which is 4, because both go into 4. And then how many times do we have to multiply 2 by to get the 4? We have to multiply it by 2, so then we multiply the 1 by a 2 as well. So we get 2 over 3/4. To solve that, we invert and multiply. So we get 8 over 3. That would be my slope. And now we can already see that if we're looking at slopes there, the slopes between the second 2 points won't be the same. So I can see that. So that's what you're doing in that particular problem, just figuring out. So I've already eliminated table 1 and trying to figure out what we need to do on that one. So let's move on to the next one.